Hi, everybody. Thank you for joining this webinar. My name's Ollie Potter, and we're going to be talking today about satellite-enabled low-power wide area networks. And kind of particularly looking at the impact of NTN. We'll describe what NTN actually means in a minute for sensor connectivity. Um, just before I start, we will share the slides after the webinar. We are recording the webinar, so that will be available as a replay. And if you have any questions, I will answer questions at the end. You can add them through the presentation, but I'll look at those questions at the end and try and answer as many of those as possible. So, right, 2 seconds. Who am I? So I'm Ollie Potter. I'm the COO here at Ground Control. I've been here for 4 years, but I've got IoT in my background. I used to be the director of IoT at Truphone, a company that's now called One Global. And I was also the digital director at Telefonica UK, or O2 in the UK, and ran the cellular IoT P&L at both of those businesses. So lots of experience in IoT, and at Ground Control, I do sort of sales, product, service, operations, and those kind of things. And outside of work, you might find me on the side of a football pitch. I coach the under 12 Rangers, so go the Rangers. Right, that's enough about me. So the conversation, why has it moved on? Like fascinating. About an hour ago, I got a press release from Amazon. So Amazon Leo is buying Global Star, or certainly announced that they're going to be buying Global Star. And that is absolutely to look at what they can do around non-terrestrial networks and providing sort of direct to cell connectivity. But obviously what happens in direct to cell, and what I see as direct to cell, is direct to a mobile phone like this one, bleeds into IoT and has an impact in the IoT market. So let's kind of ground ourselves in a bunch of scenarios. So we are talking about satellite IoT. Um, so we're inevitably going beyond where cellular coverage is for all of the time or most of the time. So we're looking at applications like those on screen, so environmental monitoring, animal tracking, agriculture. There are plenty of different sorts of use cases, and trying to work out what the right solution is for any of these sort of applications is what we're going to talk about, and what the impact of NTN is on that. One of the first considerations in IoT, and this is true in cellular IoT as much as it is in satellite IoT, is kind of, well, where are the sensors? Where are they going to be? How close are they going to be to each other? And do you need to connect those sensors individually, or can you aggregate those sensors? So in a sort of office environment, you might be using a local Wi-Fi network or a Zigbee or Bluetooth network to connect things. But then you put that out into an industrial site, you might use private 4G, and then you go further afield and you're looking at sensors that are further apart. And that might be around an agricultural site, or possibly a mine, or an oil and gas plant. You might then look at other technologies to connect sensors that are further apart. Uh, uh, when we look at satellite, kind of a main way of doing that would be, and I'll sort of go into it, was to use a technology like LoRaWAN. So this enables you to connect lots of sensors at a very low individual cost with a long battery life to a kind of main gateway. And that main gateway, if I take the example of an agricultural site, might be on a farm building. There may be a Starlink connection there, or even a fiber connection there, which you could then leverage to provide a local LoRaWAN network. And this would enable you, with line of sight, but over a number of kilometers, to connect different sensors together. This sort of way of aggregating sensors is obviously very powerful because it reduces the per sensor costs if you've got the right density of sensors, the right number of them in a particular area. And you can get them all to talk to that gateway. So they need to be able to authenticate onto whatever that gateway might be, which means a level of coordination, particularly if you've got different suppliers and different technologies around that site. Obviously, then the other side of it is things are further apart, and the idea of putting in some sort of aggregation network is too difficult. And you might have assets in the oceans or in the mountains or still in farmlands and mining sites. Um, and clearly, one of the big advantages here is yeah, you can put them literally anywhere on the planet. So if I move this forward, so you can put it anywhere. If things are moving inside and outside of where I guess a private 4G or a LoRaWAN network might be, they continue to work. The other big side of this, of course, then is if you take your farmland, my farmland example, the organization that does soil moisture might want to do soil moisture as a service and provide a full service with it, and they cannot be getting involved with connecting to a proprietary LoRaWAN network or some other kind of network within the agricultural site. And that might be true of a farm or anything as well. So getting individually connected sensors to work has loads of benefits from your business model, in addition to the location that they are in. And this is kind of really where I think NTN starts to play. It starts to look at how this model particularly becomes more cost effective, enabling there to be more new use cases and more connected devices. So just to kind of, yeah, to give you an example, so we have a customer, American Signal Corporation. They do a tsunami warning system. We have with them remotely connected sensors in the ocean that are looking for seismic activity to understand when tsunamis might be triggered. They can't be meshed together in any sort of LoRaWAN or other sort of network. They are individually connected, a really wide apart. And then that uses the satellite network in order to provide a warning, and then those warnings can be triggered in vulnerable coastal areas. So the choice between aggregating your connectivity and having individually connected sensors has often depended on these things. How many sensors have you got, kind of particularly in a small geographic area? So if you've got lots and lots of sensors in a small area, it may well make a lot of sense to aggregate those together. But as soon as they become wider apart, then you absolutely have to think about individually connected. Are they fixed or mobile? Clearly, mobile sensors will need to be connected in an array of different areas, and authenticating on different networks like LoRaWAN will become problematic. Distance between sensors, density of sensors, I've sort of covered that one. There's clearly a cost of building some infrastructure, and that depends on, I guess, where your site is and the technology you choose. Are you doing a private 4G network? Are you doing a LoRaWAN? These don't have to be very expensive, but it depends on the environment you're on. The terrain between sensors is critical. So if you've got line of sight issues, if you're in a mountainous region, then actually using a local network becomes more problematic. You know, a radio network or a LoRaWAN network won't bend round corners, unfortunately. Power has been an important one. So the local low power networks obviously can enable sensors in the field to last for a long time. But actually the latest directly connected networks are super low power as well if they're configured in the right way. So let's get into it. NTN doesn't replace these two models. It starts to change the economics of the individually connected model. We think it makes it more compelling, and we think there'll be more use cases that can leverage this. So it supports direct-to-sensor connectivity. It significantly, I think it drives down the potential cost of new hardware in the field. And that's one of the biggest drivers of the economics of developing hardware. You're going from a sort of more proprietary satellite modem, which was probably cost, $100, a couple of $100, down to 20, maybe sort of dollars for a more off-the-shelf 3GPP NTN connected module that then you can build your device around. So it's starting to enable you to have cheaper devices in the field, but it's not a replacement for everything. And I'll show you some graphs in a minute. It's not a replacement for everything. It's really suited to low bandwidth applications. I think for me, the tipping point is around the sort of 10 to 20 kilobytes, under 10 to 20 kilobytes a month. I think this is a really interesting set of technologies to consider. Above that, then the economics for me fall apart based on the costs that are out there. Um, so I think it's a really interesting technology, and it's starting to lower the costs. So what really is NTN? So NTN is a short name for non-terrestrial network, which any satellite network actually is. But what everyone's referring to is here is the 3GPP standard, particularly narrowband IoT, but also Cat1 as well, delivered over a satellite, where a sort of more standard off-the-shelf module will be able to connect to it. It's the narrowband IoT is optimized for very low data volumes. So you're using UDP or non-IP data delivery in order to send your messages there. The economics of it are quite compelling if you're sending infrequent messages. So I think you're looking at sort of twice a day, maybe four times a day for a fairly small packet of information that you're sending from your device. If you're starting to get, as I said before, sort of above the sort of 10, 20 kilobytes a month, then the costs don't look as compelling, and you're probably better off with a different technology. Widely dispersed assets, as we've talked about before, clearly, if you can hook onto an existing network and you can authenticate on it, and that network is free, then you should absolutely do that. But this is really for those sort of individually connected sensors. Scale point is a big one. So leveraging maybe the cellular IoT scale of your hardware build in order to get your hardware costs down to a really compelling level, will then enable you to then drive down the cost of satellite hardware. That will be a new thing. I haven't seen that yet in the market, but I think that's where most promise is. Can you do 100,000 of these connected devices? Can you therefore get that scale manufacturing benefit, and then reduce the overall cost or the total cost of ownership of the solution that you're taking to market? So it's promising. With still some maturity to go, I think there isn't yet global coverage. It's supported over Europe and America and I think Australia and a few other regions. There's no coverage yet over the oceans, no coverage in a number of other markets. But you've got an offer through Skylo's confederation of some geo networks. You've got Viasat launching their service on their satellites. You've got Iridium announced theirs. And then you have obviously the likes of Starlink and AST Space Mobile, and actually Amazon buying Globalstar as of today, apparently. So you've got some really interesting developments that are coming down the line as well. So while the coverage at the moment is in its very early days, that should improve in the coming 2 or 3 years and get a lot better. So I guess in this slide, what we're trying to illustrate is there's definitely been use cases we've worked on for a number of years where it's made sense to aggregate your sensors around a mining site, around a farm, those kind of areas that we've been thinking, because individually connecting every sensor has been quite expensive. But if you leverage the benefits of NTNs, you're able to use the lower cost modules, you're able to put that through a scale manufacturer in process. That tipping point moves so that we can see more of the market making more sense to be individually connected. And that will then enable you to have new business models. If you're not relying on authenticating on a local network or having to build out local infrastructure, your assets can work across a number of different sites and provide a service to your end customers. But NTN's impact on the market, as ever, is a competitive threat to what's been there before, and everybody's moving, and that creates more opportunities and makes satellite IoT more compelling in a wider set of use cases. So Iridium have announced the 9604, which is their SBD, it will be their SBD latest module. That incorporates LTE-M from a cellular perspective and SBD from a satellite perspective in a single module that I believe will be lower cost than the existing modules. So you've then got an interesting sort of best of satellite, probably, and cellular connectivity in a single module. So that becomes interesting. The Iridium 9704 is the elder sibling to SBD. So the IMT is the technology. It can do messages up to 100 kilobytes. This enables a significant reduction in the cost per kilobyte. So if you're sending more sensor data or you're trying to send kind of richer payloads, this becomes very powerful. This launched, I don't know, a year and a half ago. I'm seeing significant uptake of that, and it changes the economics of those slightly higher use cases, probably above 20 kilobytes per month. OGX is the latest iteration of what used to be called IDP. And OGX, just like IMT, enables up to 100 kilobyte messages. And again, just like IMT, is materially cheaper on a per kilobyte basis as you get to the slightly larger amounts of data. So again, kind of above 20 kilobytes than what was there before. But those two services, you can get to 1-2 megabytes a month, and it really becomes quite interesting based on the economics they now offer versus what was there before. And then if you rewind a few years ago, there was loads of noise about new CubeSat satellite networks, and Kineis is really the only one that's fully launched. So they've got 24 satellites in orbit around the world. They have their new module, and it's a very cheap, very low power and kind of compelling network as well. So the choices for satellite IoT have got broader, and I think the competitive threat of NTN has really helped everybody move into the right place. So prices have come down, services have got better. You can kind of have more for less. So we're really getting there, but it's not quite there today. So we've got test devices. We're playing with NTN. We've got some really good experience. We've helped some customers deploy, again, really test services at this stage. But it's about scale manufacture, about really getting millions of devices, I think, from a network perspective, but I think in an individual use case perspective, getting 100,000 or more devices out there to get that really kind of compelling hardware cost that then can leverage the lower airtime as well. So I've put together on my next chart a complicated graph that I'm going to take a few minutes to explain to you, but this is kind of what I think is going on. And I don't know if you can't speak to me, but hopefully you can see my mouse. So I've split this into three vertical columns. So on the far left is the space I think that is most impacted by NTN and the kind of new CubeSats like Kineis. This is below 10 kilobytes a month, maybe 20 kilobytes a month. It's about that sort of volume per month. This is where I'm seeing a substantial discount in the cost per kilobyte that the satellite networks are offering. If you couple that with scale manufacture, you can imagine sort of reaching a new level of total cost of ownership for a directly connected satellite IoT device. So I think that is the really interesting space from NTN. It's small payloads, small amounts of data in a very low cost device, and that becomes very compelling. The next column is the sort of the IMT and OGX column. This is where I would estimate 20 kilobytes, probably all the way up to 20 megabytes of data. Those have had a meaningful discount. My graphs, sorry, you can see they're just smooth lines. You can come and talk to us. We can absolutely talk to you about the sort of discounts for any particular use case. But there have been real discounts in the cost per kilobyte from adopting IMT or even OGX. And those are really in what I would call the sweet spot of volume that is currently in the market. So if you look at the green shape, the green shape is my estimate of the number of IoT devices out there. There have been lots and lots of them that are in that sort of 20-ish kilobyte space. Um, and that's where the market has been to date. Um, and there is a big discount there. So my point B at the very top is, does that grow? Does there become more connected devices? And I think the answer is absolutely yes. My point A on the chart is, I suspect in 3 years' time, when these networks are out there, when people have done some scale manufacture around the new modules, you'll see that shape shift to the left and grow to the left. So I think you'll see a substantial number of connected devices on the left-hand side that to date haven't been economically viable. And the only way to do those things has been to have some sort of aggregation, like we've talked about LoRaWAN. But many more business models and things will be enabled now because the costs are coming down. And then on the far right, there's a continuum. There are lots of technologies out there, Certus 100 to 700, BGAN M2M, and some of the VSAT services. But Starlink has really had an impact at the highest end. Clearly, you've got an amount of power that has substantially decreased the cost per kilobyte. They'd already done it in 2024, hence why there's not a massive discount showing here. I think a lot of that discount has already happened, but less relevant in IoT. That's for connected ships and residential homes and offices and satellite pop-up offices and mining sites and things like that. For actual sort of sensor connected, there isn't so much of that, and therefore the volumes are correspondingly lower. So that's my prediction of what's going on. Is that really this webinar is focused on that very first column. Um, you have a lower cost module. You've got lower cost airtime. Uh, in order to benefit from the lower cost module, you've got to do scale manufacture to get the volumes to make that really make sense. But you then have a much lower total cost of ownership than you've had in the past, and you could then develop new business models and roll out use cases that haven't been economically viable with the technologies that have existed so far to date. So I think it's very, very exciting. My conclusion slide then here is, of course, we've talked about quite a lot. So what you choose as a network technology depends on a lot of different things. How much data are you planning to send? Are you planning to stream that data or lots of different individual messages? Can you group it into bigger messages? That will determine the power you require, the sort of connection type you require, but also the economics of that particular connection. So as we said, in my mind, somewhere around 10 kilobytes and lower, NTN becomes very powerful using narrowband IoT. Above that, there are a series of really good choices that have also reduced in price in the last year or so. The number of endpoints you are going to have clearly makes a difference. We talked about aggregated and dispersed, but clearly your ability to authenticate on a local network is a challenge as well. And if you're rolling out something that's going to be a service to multiple farms or multiple mining sites or multiple whatever it might be, you want to have control of that connectivity, and NTN will help you and will reduce the cost of doing that. Things like where it is on the planet, the geography, clearly important. Not all satellite networks are global. You've got to have a view of the sky. Can't be in the underground. You can't be in a dense urban environment unless you're near the roof. You need to see the sky. Power is clearly a consideration for many, many use cases. Usefully, nearly all of these, certainly message-based technologies, are low power, and if you manage them in the right way to conserve power, they can all provide 10-year battery lives based on the experience that we've had. And then time to market. So I think NTN is something that can be tested now and played with now, and in certain regions you can probably start to roll it out. But there is a lot of change coming with announcements like the one today, meaning there are going to be changes in the business models, or sorry, in the available networks that you might be able to connect to. So I think it's an exciting time, lots of new options that are coming to market. But at the end of the day, come and speak to someone like us. We can help you. We can help you with those trade-offs. We can help you understand the costs and the considerations you might have. So I'm going to put my final slide on there. If you've got any questions, you can email me or you can visit our website at Ground Control. And me and my team are very keen to help you with any of those sort of things you might have.